This is video 20.1. We will be looking at simple circuits with resistors in series and in parallel. The question: two 200 ohm resistors are connected in series in circuit A and in parallel in circuit B to a 12 volt battery as shown below. We'd like to know what is the current through each resistor, and what is the equivalent resistance of each circuit. Let's start by looking at circuit A. The total voltage drop around the circuit is equal to the sum of the voltage drops through each resistor. Because the current has to pass through resistor 1 and resistor 2, the same current, this is simply equal to IR of resistor 1 and IR of resistor 2 using Ohm's law. Separating out the current I, we have R1 plus R2 times I. We can solve for the current, plug in the values that we know, and we find a current of 0.03 amps, which is also 30 milliamps. Now once again, the reason we knew that the same current passed through R1 and R2 is because the resistors are in series. If you imagine water flowing through the circuit, all of the water that passes through resistor 1 has to pass through resistor 2 because there's no other route for the water to pass through. However, when they're in parallel, things are a bit different, as we're about to see. Now let's find the total resistance for circuit A. The resistors are in series, so we just have to sum the resistances of each resistor. And this gives us a total value of the resistance of 400 ohms. Now let's do the same thing for diagram B. Note that when resistors are in parallel, they have the same voltage across them. To see why this is the case, examine the circuit B. The left side is just one wire, and wires are at a constant voltage, and in this case it's held at 12 volts because it's connected to the positive side of the battery. Similarly, on the right side, this is just one wire, and the whole wire is at 0 volts. Because the left end of resistor 1 and resistor 2 are connected to the left wire, they're at 12 volts. And on the right side, they're at 0 volts. So the potential difference across both resistors is 12 volts. Keeping this in mind, we can find the total current passing through the circuit, which is the sum of the currents passing through resistor 1 and resistor 2. Using Ohm's law, we can find an expression in terms of the quantities we know. Plugging in our numbers, we find the total current to be 0.12 amps. Notice that this is 4 times larger than the total current passing through A. You can think of this intuitively as the current or the electrons have more paths to go through. They can go through resistor 1 or resistor 2. Now let's find the total resistance for circuit B. We can find this with a straightforward application of Ohm's law. We know the voltage and the total current. We plug them in, and we find the total resistance to be 100 volts. Once again, this resistance is 4 times less than the resistance for circuit A. And that concludes video 20.1. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.